This conference will now be recorded. This conference will now be recorded.
So once again, good morning everyone. So today second day. So would like to give one update, guys. So guys, you will get a messages from our admin team. So please save the contact number. Save the contact number so that the recordings will be open. Okay, some people we already for interested candidates we already sent a message. Okay, so the links will be open after you save the contact number. That is one thing. And those who are all interested for the course, guys, so we already provided the details, so I will provide the drive access. So here, guys, so for suppose consider, so here you will get the drive with this name. So you will get this drive access, guys. I'm going to share this one. Okay, so for suppose I shared to one person. Okay, so here after you log in, okay, so go to your, for suppose I'm going to go to Gmail. I shared the drive access to the mail ID. So here what you have to do, guys, go to your drive. So provided after I provided access to you, go to your Google Drive. Guys, some people are entered different backgrounds, so I'm explaining. That's why I'm explaining with the basic. So here, guys, you can go to with the folder shared with me. Click this folder. So here you can see the folder. Now, after you clicked shade with me, you can see this folder. When I open this folder, here you can see the demo sessions. From tomorrow onwards, I will start with the Python sessions. You will get the folder access so that you can open and you can see the recording as well as notes. So yesterday, whatever we discussed, so we'll be having a day one, day two, day three like that. Notes will be there. You can go through the notes. So those who are all interested, message me in WhatsApp, guys. We'll provide the drive access. So those who are all interested to continue the course, so you can message me in WhatsApp. So after the session, our team will provide the drive access. Provide the drive access. Okay. Now, so coming to today's session, guys. So first of all, last class we discussed what is a data. So we discussed what is database, what is a ETL, what is the difference between a database versus data warehouse, and what is cloud computing, and we discussed roles and responsibilities of data engineer. Okay, now, and I said data is a collection of raw facts. So whatever the characters, audio, video, images, so whatever the data is generating, so this data we are going to maintain in the database. And ETL is a process to move the data from source to target. Source can be anything, target can be anything. A database, OLTP operations, less amount of data is stored in the database. A data warehouse, huge amount of data is going to store mainly for historical loads. Cloud computing, on demand of through internet, we can access the cloud provided services based on our requirement. on demand of IT services over the internet, and we can use those services and you can pay for it. So the main responsibilities of data engineer is, so we have to get the data, clean the data, transform the data, and as per the business requirement we have to provide the transformations, and we have to provide the data to the reporting team. So those are all the responsibilities of data engineer. So today we are going to discuss a few more things, guys. So today we are going to discuss, one is what is big data. So what are the problems with big data? Why traditional databases does not able to handle big data? How Hadoop and cloud overcome big data challenges? And so what are the course content? I'm going to explain each and everything in detail, so what we are going to learn. So course content I'm going to explain. Okay, guys, here in the Azure data engineering, in the nowadays, okay, nowadays, so the responsibilities of the data engineer is mainly to handle the big data related. Guys, those who are all entire different background, you may not able to understand this one. So for experienced guys, they can able to understand. For you, tomorrow onwards I will start with the Python. Okay, so today it's a kind of data engineering related, what are the things a data engineer is going to do in the cloud. So those I am going to discuss today. So if you are able to understand, well and good, guys, otherwise go through the recording. But tomorrow onwards completely actual sessions will be started today, also a demo session. So roles and responsibilities of the data engineer I'm going to discuss today. Coming to here, so what is big data? What is big data? Okay, now guys, I will share the details. Okay, now what is big data? Guys, big data, it is not any programming language, it is not a software, it is not any database, just it is a logical term. It is a logical term. For suppose if any of the data is having three characteristics, three V's, okay, which is having a characteristics. Some people are saying 5 V's, 7 V's, 9 V's, but mainly three V's. If any data is having three characteristics, then we can call it as a big data. One is volume point of view, another one is velocity point of view, another one is a variety point of view. One is volume point of view, another one is velocity, and another one is variety. What is volume point of view? Huge amount of data, where we can see the huge amount of data nowadays, mainly social media. After 2010, guys, so Facebook, Instagram, YouTube, okay, so once this digital, okay, digital era is came into picture, so there is a huge amount of data is going to generate. Okay, so for suppose consider Gmail. In the Gmail, attachment size is 25 MB. Now if you are trying to attach 30 MB, then Gmail point of view, it's big data. You are trying to insert a data more than its capacity. Okay, so volume point of view is a huge amount of data, where we can see huge amount of data nowadays, mainly social media. And also industry is also maintaining the big data, maintaining big data, so mainly to do predictions. For suppose consider I'm the Flipkart customer. I'm the Flipkart customer. Flipkart is going to maintain 6 months of my data. For suppose they don't have a capacity, they want to maintain normal data. So for suppose they are maintaining the 6 months of data. By observing last 6 months of data, they are observing my purchase patterns. So what are all the products I purchased more on last 6 months? Consider I purchased more on baby products. Because of my 6 months data, Flipkart team decided this candidate purchasing more on baby products, so they can predict that this candidate next 1 year also he is going to purchase more on it, so that they will run the campaign. So they will do the predictions, they will run the campaigns until they will generate the offers. You will get an emails about the baby products related. So the same Flipkart, for suppose they are maintaining 2 years of data. So 2 years back I purchased a mobile. Then they predict that 2 years back this candidate 2 years back this candidate purchased a mobile, so he may change the mobile. So you will get a mobile offers. So because of the data, they are going to predict about purchasing. The patterns they are going to predict more. Similar way. For suppose I am having the ICICI customer and here, and I am having a credit card. So which is having, and this ICICI is going to maintain 1 year data. So I have a credit card. So credit card limit is 1 lakh. Credit card is 1 lakh. So last 1 year they are maintaining only 1 year data. By seeing my 1 year data, they observe that this candidate paying credit card amount on time, so they are going to increase the capacity from 1 lakh to 3 lakhs. 1 lakh to 3 lakhs they want to increase the capacity, because they check my last 1 year transactions. For suppose the same ICICI, they are going to maintain 3 years of data. Okay, now credit card related, to increase the limit, they check my last 3 years transactions repayment. So they observe that first 2 years I did not paid on time, only last 1 year I paid on time. So they don't want to take a risk, and they increase the limit from 1 lakh to 1 lakh 5 lakhs. So 1.5 lakhs only. So because they are maintaining the huge amount of data, they predict about my card repayment. Okay, so that they can predict that, so this candidate may be risk, so they are increasing capacity limit from 1 lakh to 1.5 lakh. So like that, so industry is also maintain the huge amount of data to do the predictions and all. Okay, that is one thing. Velocity point of view, high speed generating data, nothing but streaming data, continuously generating the data. Example, CC cam. Okay, any sensors data. So CC cam, if you observe, morning the capacity is in terms of KBs, at end of the day it can be MBs, continuously generating the data. So that is one thing. And variety point of view, different categories of the data: structured data, semi-structured data, and unstructured data. Structured data, consider delimited files, tables. Okay, we can see structured data. Semi-structured data, XML files, JSON files. Okay, unstructured data, audio files, video files, images. So these are all unstructured data. So here, so this big data, as you see, huge amount of data is generating with different categories. Now, if the data is huge, what are the challenges we have? Challenges of big data. Okay, so if the data is increasing more, what are the challenges are there? One is how to store the data. Another one is how to process the data. One is how to store the data. Another one is how to process the data. Means if the data is increasing, somewhere we have to maintain it. Once data we are maintaining, as per the requirement, we have to process the data. Process means, for suppose consider I have a one basket which is having 10 fruits, out of which 9 apples, 1 mango. Now I want to find the mango. Then here we are going to do search operation here. Here we are going to do search operation. That is a process. You have to process entire data and you have to fetch your required thing. So if the data is huge, if the data is huge, here also I want to. So for suppose here I am having this one and I am having this one. So here also we have to find the mango. So if the data is also increasing, okay, huge data, I want to process the data. So that is also one of the challenges. These two challenges are overcome by Hadoop. So these big data challenges are overcome by Hadoop and cloud environments. So like Azure. So all cloud environments overcome this challenge. So here in the Hadoop, this is completely manually. So no, but now people are not using the Hadoop. Everybody using the cloud only. But still, people are learning Hadoop related, guys. Even if you go for opportunity related, whatever you can do in the Hadoop, everything better way we can do in the cloud. Okay. So now we are going to do everything in the cloud. So how do this handle the big data related? Okay. Now here I said in the last class, the data here we are going to maintain in the database, okay? Or in the you can maintain in the data warehouse. Huge amount of data we can maintain in the database, historical data in the data warehouse. Though we are going to maintain, we can maintain the data warehouse. Then why these are all came into picture? Why these are all came into picture? Because here also we are generating the data, but huge amount of data, the traditional databases and data warehouse. So though they are exist, then why we are used this one? So here what happened is there are, so here why traditional databases or warehouses does not handle big data? Why those are all not able to handle? Okay, so we'll discuss. Guys, I'm repeating, those who are all freshers may not able to understand this one. From tomorrow onwards, for Python onwards, it will be actual course will be started. So today also data engineering demo only. So you can plan accordingly. So by seeing all these terminologies, okay, don't think data engineering is a complex like that. Don't think like that. But here I can see some experienced guys. So mainly those point of view, I'm covering this topic, guys. Now coming to traditional databases, why it does not able to handle? So storage related, what is the problem? Processing related, what is the problem? So storage related, guys, okay, so here we can analyze in terms of scaling. There is a two types of scaling: vertical scaling and horizontal scaling. Vertical scaling and horizontal scaling. So here consider, so I'm saying big data is the huge amount of data. These traditional databases are not able to handle. In storage point of view, why these are all not able to handle? I will tell you. Consider I am having a laptop. Okay, consider I am having a system. So which is having 4 GB RAM. Okay, 1 TB hard disk. So here I am going to running four applications of data. Four applications of data I am running. It is working fine. Now what happened is I want to increasing four more applications of data. I want to add four more apps data. So to do that, I'm going to increase the capacity of this one. I'm going to increase the capacity of this one from 4 GB to 8 GB and 1 TB to 2 TB hard disk. So the same system capacity I increased 4 GB to 8 GB. And if the data is increasing more, I'm going to increase the same system capacity. So here in the vertical scaling, okay, vertical scaling as per the requirement, so we are going to increasing the same system configuration. Okay, so for suppose if you go to any laptop, if you purchase any laptop, they said that boss, this RAM is 8 GB, this can be extend up to 64 GB. The laptop can be extend up to 64 GB. They are saying like that, means the laptop can be support up to 64 GB, but right now it is 8 GB. If you want to increase, you can increase up to 64 GB. So here in the vertical scaling, as per the requirement, we can change the same system configuration, we can increase. That is in the vertical scaling. And we have one more thing, horizontal scaling. Horizontal scaling means, here consider I'm having a system. Okay, so in this system, as I said, this is the capacity. So here I am having, so 4 GB of data, 4 GB of RAM, 1 TB hard disk. Here I'm running 4 applications of data. For suppose if you want to add a few more things, if you want to add a few more things, instead of changing this one, I can add one more node, one more system. Sorry, I can add one more laptop. Consider laptop. These two systems are connected over the network so that information exchange between the systems will be happen. Now, so this can be any capacity. So this is not mandatory 4 GB. Okay, it can be 8 GB RAM. It can be 1 TB hard disk. So if the data is increasing more, if I want to add a few more, so I can increase the one more system. Increase the one more system. Okay, and here we can increase the capacity. It is one more system. Okay, now here what happened, guys? So horizontal scaling means as per the requirement, multiple systems we can add over the network. So this collection of systems, we can call it as a cluster. This collection of systems, we can call it as a cluster. So here, if the system inside a cluster, we can call it as a node. We can call it as a node. Now I can say this one as a 3 node cluster. Okay, so here I can say this one as a 3 nodes cluster. So in the horizontal scaling, as per the requirement, we can add the number of nodes. This is the horizontal scaling. So this is a collection of systems, we can call it as a cluster. The system inside a cluster, we can call it as a node. Now I can say this one as a 3 node cluster. 3 nodes cluster. Okay, now save as. Okay, now here what happened is, all these traditional databases like Oracle, SQL Server, Teradata, all are multiple systems are there, types of databases, database management systems. Everything is supported horizontal scaling. If the data is increasing, we can add a node. But here what happened is, there is a limitation in the number of nodes. Here it can support up to 128 nodes. Here it can support up to 256 nodes. But here big data is having more than that. So the use data is generating, it is having more than that. So traditional databases does not able to handle that one, so which is overcome by the Hadoop and cloud. Hadoop and cloud, here we can support the unlimited number of nodes here. Okay, so here backend we are having a ADLS, Azure Data Lake Storage, so where we can maintain the storage account. So backend, the systems will be connected over horizontally. So horizontal scaling will be there. Huge amount of data it can handle. So here, what you have to understand is, there is a big data, huge amount of data. Traditional databases does not able to handle because there is a limitation in the number of nodes. But Hadoop and cloud, Azure, so there is a unlimited number of nodes. So if the data is increasing, the nodes will be added to the network. So that is one thing. So that is the storage related. Coming to processing related. So coming to processing related. So here there is a two types of processing. One is non-distributed data processing. Another one is a distributed data processing. Non-distributed data processing, and another one is a distributed data processing. So here guys, For suppose I am having a data. Okay, I am having a file. The file capacity is 300 MB. Accounts.txt. So which is having 300 MB capacity. 300 MB capacity. So here what happened is, if it is a non-distributed data, okay, for suppose I am having a system. Okay, if it is a non-distributed, so here whatever the data, entire data will be in one of the node, one of the system. So here for suppose I want to process the system, so here I want to calculate, select count star from accounts. So here what happened is, it is going to run this one, entire thing will be run here. Okay, entire thing will be run here. So this is the non-distributed data processing. So data is not distributed. So entire thing, for suppose your processing speed is 1 MB per second, your processing speed is 1 MB per second, total I have a 300 MB, so 300 seconds it is going to take to process the data. Now the same thing, if it is a distributed data processing, so here what happened is, so whatever the data, so here in the distributed data processing, as I said, we are having a horizontal scaling. So multiple nodes connected over each other. Okay, it's a kind of master slave architecture. So multiple nodes connect over each other. Okay, so here what happened is, consider this is a 3 node. So all are connected over the network. Now here it is this one. So whatever the data is divided into the blocks. Okay, the data is divided into the blocks B1 and B2. So it is divided into the blocks based on the block size. Okay, so multiple blocks we can create. The blocks will be stored here, B1 and B2. For suppose if I am running the query here, the same query I am running here. So here what happened is a parallel processing will be happen. Okay, so here we can do parallel processing, so the performance will be increased, and here you can see the capacity 1 MB per second. So parallel processing will be there, so 150 seconds it is going to complete, it is going to take to complete the process. Here what you have to understand is, in the distributed data processing, whatever the data will be divided into the blocks are distributed between the nodes, parallel processing will be happen, so fast processing will be there, here traditional databases also following the distributed data processing. So whatever I said, traditional databases, okay, whatever the traditional databases, these things are also following the distributed data processing, but there is a limitation in the block size. There is a limitation in block size. It is in terms of kbs only, kbs. So here Oracle 4 KB, okay, Teradata 512 KB, like in terms of KBs only. But the same thing in the Hadoop and Cloud Azure, okay, the block size is in terms of 128 MB. So when you want to extract the data, at a time it is going to give you 128 MB of data to you. If you have a small amount of data, then go for traditional databases. If you have a 100 MB, 10 MB data, you can go for traditional databases. When you go for huge amount of data, then we can go for this cloud environment, big data. To handle big data, we can go for Hadoop or cloud environment. But here, as I said, Hadoop completely manually. So last 2 decades, people are using Hadoop. Now from 2020 onwards, most of the people are using the cloud only. So that's why there is more opportunity into the cloud, and the data engineer has to deal with big data. To handle the big data, that is the responsibility of the data engineer nowadays. Okay, so here guys, for suppose those people who already working in the Hadoop guys, the same thing, instead of in the traditional environment, the same thing as it is we can do in the cloud. Similar to Azure, we can do the same thing in the AWS and GCP as well. Okay, as part of our learning Azure, okay, so we are going to discuss few things. Here, as part of our course, full stack data engineering, so end to end data engineer related responsibilities, everything we are going to implement here. So that we are going to implement in the cloud Azure, in the cloud Azure. Okay. So here, as I said, the main thing is here we are going to start with a Python programming language. Why? Because some people are entire different background people. So if you are entering into the new one, so first you have to get the confidence. Guys, here in the Python, I'm going to start with the basic, guys. From the print statement onwards, I'm going to start. Here, when you start the basic, so I will provide assignments. When you do assignments, guys, you will get a confidence. So each and every assignment related, if you get the output, if the output is an expected output, you will get a confidence. Okay. So as I said, you no need to be a master in Python, but whatever the things are required for a programming language, once you learn programming, guys, trust me, entire your career you can use that one. It can be any language, the syntaxes will be slight different, so the process is same. So for suppose here we are going to discuss variables, data types, if condition, for loop, functions, modules, oops concepts. So the same thing is available in other languages also, but the thing is now, as it is already integrated with the AI tools like Databricks. So we are using the Databricks. It is already integrated with the AI. You will get the code. You can just use the code. To use the code, we have to understand the code. After this course, you can understand that one. So I will start with the Python here. So tomorrow onwards, I will start with the Python, guys. And then we are going to discuss with the SQL and the PL SQL. Okay. As we are going to deal with the data throughout our journey, SQL is a mandatory. As I said in the last class, so here we are going to deal with data, right? As I said in the last class also, so I am having a database. To interact with the database, one language is required. To interact with the data SQL, one language is required. So to interact with the database, so we are using SQL. Guys, this SQL part I will discuss in the SQL Server, T-SQL. So SQL Server I will discuss here. So SQL related DDL commands, DML commands, joins, aggregations, window functions. Okay, those things are required. I'm going to cover these things. And also PL/SQL related cursors, stored procedures, if conditions, for loop, exception handling, triggers. So those concepts I'm going to discuss here, guys. PL/SQL. So SQL is more than fine, and here this SQL related also I'm going to provide in terms of assignments, guys. Okay, so everything in terms of assignments I will provide. So theoretical, you can go to the YouTube, you will get a tons of material, guys, as I said already. So completely practical oriented in terms of assignments, I will make you get ready for this Python and SQL. If you go for any interview, whether you're 2 years or 15 years, people are expecting basics of coding, guys. SQL and Python. If you mentioned your resume as a data engineer, okay, so these two things are very, very important. So anyway, in the real time, okay, for suppose you can search in the Google or anyway you can get the code and all, but in the interview point of view, you have to understand. So there are standard around 100 to 150 questions, guys. That is mostly people are asking the questions, and those scenarios, most of the scenarios it is going to cover. I will discuss those things also. So I will make you ready for interview as well. So Python and SQL, and then we are going to discuss about the data warehousing concepts. So traditionally, we are going to build the data warehouse. As I said, okay, 1 second. As I said, guys, online folks, I will address the questions. Give me 5 minutes, okay? So here you can see, for suppose earlier I have a, consider I am having ICICI related. Okay, so I have a source system, Visa and Master. Okay, so before cloud, before Hadoop and all, so if you are working in the traditional databases, what happened is, so people are maintaining the Linux machines here. Linux servers are there. So they are going to keep the data in terms of files. Now here also consider these people are maintaining the Linux file system. So using any shell script, they are going to ingest the data into here. They are going to ingest the data into here, and then so these people is having their own data warehouse, and here whatever the files you received. So here I am going to receive the files like this. So whatever the files are there, using any ETL tools like Informatica Talend, so whatever the files you are going to maintain in the data warehouse. Earlier your responsibility is to organize the data warehouse, guys. So because entire historical data I'm going to maintain here for the business, from here we are going to generate the reports. Here earlier data engineer responsibility is to organize the data warehouse. Okay, so to understand what are the concepts in the data warehouse, okay, star schema, snowflake schema, dimension tables, fact tables, normal form, okay, normalizations. So those concepts I am going to discuss here. Even though we are not building the data warehouse, the similar kind of thing we are going to build in the lake, in the cloud. So I will tell you. So that's why if you go for any interview, people will ask the data warehousing concepts, guys. Okay, so inman schema, skinban schema, star schema, snowflake schema, and normalizations and normal forms, dimension tables, fact tables, those are all the concepts are required. So these are all mostly theoretical related, so those things are also I'm going to cover. And here we have to understand one more thing coming to cloud related. As I said, we are having a big data, right? Huge amount of data, right? So these traditional data warehouses, those are all does not able to handle the big data. So that's why, so there is a data lake came into picture. So here, so there is a data lake. So there is a data lake. So there is a, as you know, database versus a data warehouse versus data lake. Data lake versus a data lake house. Okay, guys, here we have seen last class database where OLTP operations, transactional database, a data warehouse, historical data, we can maintain huge amount of data we can maintain here. I prepared the this one diagrams also. We discussed the diagrams also. Okay, now well, let me take this one. So here you can see database. So OLTP operations, less amount of data is there using ETL. We are going to maintain in the data warehouse. In the data warehouse, historical data we are going to maintain. Then what is the data lake? What is data lake? Just now I said we are having a big data, right? Huge amount of data, right? So this traditional data warehouse does not handle the big data because there is a limitation up to certain amount of data only it can store. To handle this one, data lake came into picture. Here, as per the requirement, multiple nodes we can add. Multiple systems connected over the network. So here this is having a hard disk. Okay, this is nothing but a file system. These file systems are connected each other, and here, so we can build the file system here. So once you enter the data will be distributed between the nodes. So if the data is increasing, we can add. That's why you can see data centers, which is having a multiple data nodes. Okay, so this data lake, which is a distributed file system. Distributed file system mainly to handle the big data. So here guys, we can store all categories of the data, structured data, semi-structured data, unstructured data. It is a kind of dumping yard, guys. Everything and we can dump here. Unlimited data it can support. Everything we can maintain here. For suppose banking related ICICI. So here I can ingest the credit card data, debit card data, loans data. So whatever the data I can maintain here, because huge data it is going to maintain. So that's why in the industry people are building the data platform. So once everything is here, a data science people or anybody can access the data, because everything is here. Earlier we are having a different data warehouses. Now a data engineer responsibility is to build this data platform. Okay, so here what happened is, here in the data lake it does not supports the update. So whatever the data warehouse supports, okay, acid properties, updates, okay, those things it doesn't support. It is only supports the file system only. So to avoid that one, we are having in the recently we are having a data lake house. A data lake house which is having a features of both data lake plus a data warehouse. So here, whatever here as it is we can build. Whatever here as it is we can build. On top of this we can build the warehouse also. We can build the data warehouse also. So it's going to support both big data and data warehousing concepts. So both it can support in the data lake house. So there is a delta lake, there is a delta format. So using that we can maintain this one here in the data lake house. Guys, coming classes I will discuss all those things. Okay, so you no need to worry. So here what happened is, so to handle the big data related, so big data storage related, we are having Azure storage account. So here we are going to discuss ADLS. Okay, as I said, data lake, Azure data lake storage. So this is the Azure data lake storage. As I said, data lake means huge amount of data. So here what happened is, consider, so to maintain huge data, instead of maintaining your own environment, cloud Azure is going to say, boss, we are having a data lake. So there are backend, we are maintaining that one. Backend, we are maintaining that one. So as per the requirement, you can use this one. So here what I am doing is, I am building the ADLS. Guys, working people, the way you are traditionally maintaining the Linux file system, that is individual. The same thing we can maintain in the ADLS Azure Data Lake storage, unlimited data it can support. So for suppose this ICICI related, they are going to building this one. So they are having a source systems. Consider their Visa, their debit cards and credit cards are they're maintaining in the another third party one, Visa and Master. They are going to maintain the transaction data. Similar way, so some people are there maintaining the loans data. So like multiple source systems are there. Multiple source systems are there. Be a data engineer, your responsibility is whatever your data you have to ingest here. So for suppose I am working here as a data engineer, so my responsibility is mine related data is going to maintain here. I have to get the data into here. So because it can support unlimited data, so here what I am doing is, I want to get my data into here. I want to get my data into here. So we have to get the data into here. So it is extract the data, loaded into here. Meanwhile, if you want to apply the transformations, we can apply. So here for this we are using ADF, Azure Data Factory. Using ADF, I can connect into any sources. Guys, experienced people, guys, your questions I will address. Give me some time, okay? So here next we are going to learn, so ETL related. So we are using ETL related, we are using Azure Data Factory. Okay, that is one thing. And then once the data is here, I want to process my data. Means for suppose I have a 1 million basket, 1 million fruits in the basket. I want to extract my required fruit. It has to scan the entire huge data. So the traditional SQL engine, those are all not able to handle that one. So here on top of this, to process the data, we are having a data bricks. On top of the file system, to process the data, we are having a data bricks. Okay, so here there is a Spark engine. Using the Spark engine, we can process the data. This is similar to, in the Oracle we have a SQL engine. Using SQL engine, we are going to extracting, you have to process the records in the table. Similar way, in the file system, to get my required info, I can use the Spark engine which is going to process the data. For suppose, in the basket I have a 10 fruits. Here can do the search operation. Here the searching is a process. So similar way, so to handle the big data related, so this big data related, for to do processing related, we are using Azure data bricks. And here the processing engine is the Spark engine. This Spark engine related code we can write in different languages. As part of our learning, we are using Python, so that's why we can call it as a PySpark. So here guys, basics of Python is required, that I am going to cover. Here I am covering more than that. So for experienced people, both core and advanced concept I am going to cover, but here basics of Python is required. Basics of Python is required. So here what happened is, so PySpark, which is contains some predefined functions are there, some predefined modules are there. So they already provided some code. You can use those code as per your requirement. That's it. You no need to write extraordinary programs here, guys. They are already provided some code. You can use the code to handle the data. So data bricks. So here data factory we are going to cover. Data bricks here we are going to cover in the Spark engine. And here one more thing is Azure SQL Server. So whatever we are going to cover in the SQL Server, the same thing is here also, but in the cloud environment. That is one thing. And we are having Azure Synapse Analytics. Here guys, what happened is, this data factory, this ADLS, Databricks, SQL Server, those are all individual components. These are all integrated in the Synapse. These are all integrated in the Synapse. Okay, so if you know remaining guys, this is the matter of 4-5 hours. That's it. Okay, so everything, our purpose is to handle the data. Okay, the data is generating from the files, tables, API. Be a data engineer, you have to organize the data as per the industry requirement. You have to organize the data in terms of tables. Whoever required, you have to provide the data for the reporting people, so that business will take a decisions on your data. Okay, that is one thing. And one more thing is Microsoft Fabric. Here Microsoft introduced a new component guys, new data engineering service. So here what happened is, Synapse along with Power BI and some data science related, real-time intelligence, streaming related, everything is there in the Fabric. Now next 1 year, after a year, next year, people will be use the Fabric. To understand the Fabric, Synapse is required. To understand the Synapse, okay, a data factory, data bricks, okay, SQL Server is required. So those are all integrated in the Fabric. If you know these components, if you know these things, okay, Fabric is also easy guys, just 10 to 15 hours, that's it. Because it is came into picture last year only, so you cannot keep 3 years as a Azure data engineer. Okay, if you learn only Fabric, you cannot say last 3 years I used Fabric, because it was invented in last 1 year only. So if you want to keep 3 years, 4 years as a Azure data engineer, you can say that, so first 2-3 years I working on the Databricks and data factory, and the last 1 year I'm working in the Fabric. You can say like that guys. Okay, and also I'm going to discuss the Power BI as well. So this Power BI is also present here in the Fabric. It is also present here, Fabric. So earlier people are using individual components. Now if you go for Fabric, so in the Fabric you can use a data factory purpose, Databricks purpose, SQL Server purpose, Power BI purpose, everything we can use the Fabric. But it is last year only, we cannot keep 3 years, 4 years in the Fabric. So you should know remaining. If you learn remaining, this is matter of 10 hours to 15 hours, that's it. Okay, and also Azure related, I'm going to discuss a few more services like Azure Key Vault. This is a small service only to maintain the secrets. Key Vault and Azure Logic Apps to send the email notifications. And also, as I told you, we are discussing end-to-end projects, guys. Two projects I will discuss. So, and then interview questions, and then a resume preparation. Okay. So these things I will discuss, guys, as part of our course. Okay, guys, my sessions. Okay, so in the live sessions, guys, you will understand only 50% only because most of the people are entire different background people. So when you go to the recording, you will understand nearly 70 to 80%, guys. When you do practice, then only you will understand 100%. Because if you observe here, most of the people doesn't know the terminology also. When you do recap, when you go for recording, then you will get a confidence. Okay, so practice is very very important for this one. Whatever the, so Azure subscription, also the free trial I'm going to provide. But in the data factory at around 1 week we have to create our own account because that is chargeable, so more chargeable. So remaining part I can provide. So one time we have to create, remaining I can provide. Anyway, Fabric is also free trial only, so those things, accesses and all I can provide. Okay, so this is about the course related, guys. So here, guys, if you put, so as I told you, those who already having knowledge on these things, guys, then they can directly go for this one. Okay, Azure data engineering related. So here, as I told you, currently my sessions will be 10 to 11:30. 10 to 11:30, guys. So tomorrow onwards I will start with the Python. So tomorrow onwards I will start with the Python. So those people are who are interested, you can attend the live sessions, guys. Otherwise I will provide the recording sessions. Whenever you have any doubts, you can connect one to one, guys. Okay, whenever you have any doubts, you can connect one to one. So learning related, so whatever the things are required, I can provide, guys. That is my responsibility, how to teach, how to make you get ready for the interviews. Okay, so any doubts, guys, online folks? Okay, let me address the questions. 1 second. Okay, can you share me the cluster class comparing vertical scaling? No, Safa. Horizontal scaling we can create. So in the non-distributed, entire thing in the one system only. So it is not distributed, but in the distributed we can. Between Databricks and data lake. So here data lake is a file system. So for suppose consider an example. I said the basket is a data lake. The searching the fruit is a processing related. So we can do Databricks. Okay, data lake is a file system. On top of this, we can do process the data. Oh, the data shown a big data with small example. Praveen, next classes I will tell you, Praveen. CI/CD, guys, here Azure DevOps I am going to cover. In the Azure DevOps repos I am going to cover. Okay, so here I will cover the Azure DevOps repos. So which is a code repository. So CI/CD implementation is the responsibility of Azure DevOps engineer. Okay, so be a data engineer, I will tell you, but in the Fabric I can tell you the deployment related. Okay, so in the Fabric it is easy to deploy the code, we can, but here in the Azure, okay, so it is difficult to do this one in the free trial. So but in the Fabric I will tell you the approach, SDLC methodology, Agile methodology. Okay, those are all interview related also I will cover. So do you provide any LMS practice purpose? Sitaram, we have a drive access. We can provide the drive access. Sujay, Power BI will be 20 classes. Power BI will be 20 classes. Okay. Guys, as I told you, nowadays industry is expecting multiple skills, guys. Industry is expecting multiple skills. So earlier, 10 years back, if I say I'm testing, I'm master in testing, okay, fine. Now developer has to do testing. Now data engineer has to be generate the reports also down the line. Okay, so people are expecting multiple skills, guys. Huge competition because of the competition also. Okay, so learning related guys, I'm simply saying one thing: spending time, money on learning is investment, not an expense. people are people are not spending the time for learning guys, people are spending time for anything. Okay, just imagine how much time you are spending for reels, watching reels, Instagram. Okay, the same time if you spend this learning related guys, okay, it will be very good to you. Okay, and also people are spending their family members related, okay, friends related, kids related, but people are not spending learning related. They are not improving themselves. Many people are in the comfort zone guys, many people are in the comfort zone. So as I said, just imagine your manager is come to your desk next week, your last working day, will you able to survive or not? Always try to learn something guys. So whether you joined or not, in the if you are, if you would like to be in the software industry, always try to learn new thing. Try to learn this year, what have you learned? What is the difference between you and your colleague? If he is learning, what about you? So what you are learning in this year? Because so those who working people guys, you already decided you will be in a software industry. So then where are you? Are you up to date or not? Okay, if you are anybody is coming with more than your skill, people obviously prefer them. So come out of the comfort zone guys. 10 years, 15 years, same company, same salary, without hikes are there. So people are scared to go out. Okay, so Saturday Sunday people think that we'll learn something. Okay, if they meet any friends, people are think like that. If they're explaining their CTC and all, people are think that we have to do something. But Monday again the same comfort zone, same routine. Okay, so try to come out of that. And guys, I will share the details. So those who are all interested, you can take the course content, you can fill a form. Okay, you can see the details guys. So you can see the course content, and here you can fill a form. And this one guys, the course duration will be 6 months. Duration is 6 months guys. So and the course fee payment is 39K. Okay, so this one you can pay 3 installments, 15K plus 15K plus 9K. So you can pay 3 installments. Similar way guys, I am having Azure data engineering guys, for working people who already having a Python and SQL knowledge, data warehousing knowledge, then you can join Azure data engineering. Here it is a 3 months duration, it will be 25K guys. Here this you can pay 2 installments, 10K you can pay 2 installments guys. Okay, so those who are all interested guys, you can message me in WhatsApp. I will provide the drive access, and tomorrow the link will be changed guys. And tomorrow onwards we are going to start with the Python for work for non-IT people, freshers guys. Today the terminology is new to you. The terminology is new to you, you may not able to understand that terminology. By see these sessions, don't think that it is complex and all. Tomorrow is the actual sessions will be started. Tomorrow onwards actual sessions will be started. We'll start from the basic. Okay, so you can plan accordingly guys. So this is for today. So first just 1 minute I'm going to recap. So here as I said, big data, that nowadays it is going to generate the huge amount of data. So the traditional data warehouse does not able to handle this one because it's a high storage. Okay, so it does not able to storage this one, and the problems are two challenges. So the traditional databases, because of the limitation in the number of nodes, okay, it cannot able to process. But the cloud and Hadoop came into picture, which is overcome the big data challenges. And here to do that, so we are having the data engineering services. So Azure related, storage related, we have a data lake storage, ETL related data factory, data bricks to handle the big data related. So the same thing is there in the fabric, and the Power BI to implement the dashboards for the business. So if you observe guys, data ingestion, transformation. So data ingestion we can do using the data factory, transformations we can do here, and then we can generate the reports. So the fabric is end to end is integrated in the fabric in the single Azure service. Okay, so this is for today guys. Any doubts you can ask me. Thank you.